All right, 3.2 is going to go over proof and perpendicular lines. So we have a couple theorems to talk about before we get into our examples. So the first one, and I'm going to shorthand it, is theorem 3.1. That's what we're going to call it, okay? The THRM is theorem for me. All right, so this says if two lines intersect to form a linear pair of two congruent angles, then the lines are perpendicular. Okay, what in the world does this mean? That means if we have a linear pair, what is a linear pair? That would be on a straight line, two angles on a straight line. So here's angle 1, here's angle 2. Okay, if this line right here that I drew diagonal, if we say that line, intersects to make two congruent angles, that would mean that these two lines would have to be perpendicular. Why? Because a straight line is equal to 180. So if angle 1 and angle 2 are equal to each other, they would each have to be 90, making the two lines perpendicular. Okay, next theorem. We have theorem 3.2. Theorem 3.2 says if two sides of two adjacent, remember adjacent are neighbors, acute, remember that's under 90, angles are perpendicular, then the angles are complementary. Okay, what does this mean? This means if we have two lines here, okay, because we have to have adjacent angles, so adjacent angles 1 and 2. Okay, so here's our two adjacent angles. So if the two angles are, if the two sides of the two adjacent angles are perpendicular, well, if that would make this one and this one. If those are perpendicular, what angle does that make? That makes a 90-degree angle. And what does that mean about angle 1 and angle 2? That would mean that angle 1 plus angle 2 would add to be 90, since those are the two small angles that form the whole. Okay? Next one, we have theorem 3.3. Okay, this one says if two lines are perpendicular, then they intersect to form four right angles. All right, so if two lines are perpendicular, what's that look like? Here's a line, here's a line. Okay, if these two lines are perpendicular, they meet at 90 degrees. Well, if they meet at 90 degrees for one angle, what do we know about all the other angles? Well, this would be a straight line, right? So this would have to be 90. This is a straight line. So if this is 90, then this is 90. And if this is 90, then this is 90. So we have four right angles. Okay? So those are our postulates. Now we're going to practice them. So, first one. The directions are going to look like this. Write the postulate. Or theorem. So other definitions and theorems that you've learned are fair game. That justifies the statements. Okay, so the first one I'm going to give you. Here's your picture. We have angle 1 and angle 2. So why can I say, or can I say, angle 1 is congruent to angle 2? All right, so look at the picture. Now, do I have a picture like that up here? No. But what do I know about these two angles? I know that these two angles are vertical. What do we know about vertical angles? They're across the street from each other. They share a vertex. They are congruent. So I can say angle 1 is congruent to angle 2 by the vertical angle theorem. Okay, let's try another one. So the next one, we're going to have this picture. And I'm going to tell you that if these two guys are congruent, then J is perpendicular to K. This is J, this is K. Well, why can I say that? Why can I say if these two angles are equal, then that would mean J is perpendicular to K? Go look back at your notes, and that would be postulate 3.1. Okay, postulate 3.1. If it's a linear pair, the two angles are congruent, they have to be perpendicular. Okay, I want you guys to try this next one. Okay, so here is your lovely picture. 1, 2, 3. So angle 1, angle 2, and angle 3 are 90. Why can you say that? Go ahead and pause the video and try that. All right, the next examples that we're going to do are going to be a little bit more solving. So now we're going to actually find the value of x. Find the value of x. So the first one, number 3. Here's our picture. Here's x. So what degree would x be? Well, let's think about our theorem. Okay, if I have two lines that meet at a 90-degree angle, from our postulates, oh look, 3.3 looks very familiar. If I have one 90-degree angle, all are 90. So what would x be equal to? 90 degrees. Okay, next one. Similar picture. Okay, here's our picture. So for this one, okay, so I have the 90-degree angle right here, which means they're all 90, which means this would have to be 90. So I can use my angle addition postulate, and I know that x plus 45 has to equal 90. Solve down for x, and x is 45 degrees. Okay, you guys try this one. Here's your picture. Say L is perpendicular to M. Go ahead and pause the video and do that one. All right, there's one more type of example that I would like for you guys to see. So for this one, the directions are, what can you conclude about the labeled angles? Okay, so the first one, this is our example 5. We have this lovely picture. Whoops. There's 1, 2. This is 90. Call this B, this C. All right, so what do we know about the two angles? Okay, what do we know about the two angles? Well, angle 1 and angle 2. We have this guy right here, right? And this guy right here that meet at 90. Well, what does that mean? If that angle's 90, where are the other angles? That would mean this guy would have to be 90. So what do we know about angle 1 and angle 2? What definition do we have for that? Angle 1 and angle 2 would be complementary. Or they add to 90. Okay, use your theorems that we learned. Try this one. N and M. N is perpendicular to M. I'm going to tell you that. So what do we know about angle 1, 2, 3, and 4? Well, from up here, if we have that picture, two lines are perpendicular, they make 4 right angles. Okay, so all right angles. It makes all right angles. Okay, you guys try this one. Once you try this one, your notes for this section are complete, and you can get started on your next task. Okay, so what can you say about these if I tell you that H is perpendicular to K? Here's H, here's K. Go ahead and pause and try that.